term costs like 127 so I beg you, please read that, because it's just one page, not that long. I've got way too many questions, so like it must be that at least like 20 of you have read it, so please read it. I was gonna do the article I sent out today, but I mean, Dr. Gaten sent me some sort of content he wanted to go over at the last minute, so I'm actually just gonna do sort of an overview of aggregate expenditure, and then do like a numerical example at the end, so we can see what that's gonna look like. And then if there's time left, I've got quite a bit to go through, so if there's time left, I'll be here for questions, but otherwise. All right. So when we say aggregate expenditure, we're talking about desired aggregate expenditure, right? So what is desired? It's kind of like a big assumption in our model, but like what do we mean by desired aggregate expenditure? Anybody have a guess? Yeah?
Like how much someone wants to consume based on what they have.
Who though?
Like
Household is one. Who else?
firms.
Firms, right? Basically households and firms, right? Government too, but like we'll get into that. So yeah, it's basically what do consumers and firms want to purchase. They look at their income, they look at their wealth, and they look at market prices and say, how much do I want to purchase? Obviously, like that's not how people think, right? But this is sort of like a device to simplify our model, right? Like you don't sit out and plan out your expenditure for the year probably. Maybe you do, I don't know. So that's 4 components. So the first one, we have A equals C. What's this one?
Consumption.
Consumption. We can decompose it into autonomous consumption and what we call induced consumption, right? So this is just intercept slope, right? So this we call, what do we call this?
The marginal propensity to consume.
Exactly. And then what's YD? Disposable income. Exactly. So that's consumption. This is what we've assumed consumption looks like, right, in our model. The next one is investment, right? And this one's pretty simple. We basically just assume that investment's a constant, right? Which is more or less reasonable. Like it's kind of a long-term thing, right? Like people aren't going to necessarily look at short-term market conditions when they're doing long-term investments. But mostly it's just there to simplify things for first and operating on. So I'm just going to leave it as is. We just assume it's a constant. However, there are some sort of exogenous shifters, right? I think he calls them ceteris paribus variables. And ceteris paribus just is Latin for all else equal, all else being the other things that affect investment, right? So what might be something that shifts investment? Like which one of the YU-PIE variables might change the level of investment?
Is it wealth?
Wealth, I think you might be thinking of WEI, which has to do with consumption, but it's the same idea. Sorry, did somebody else say something?
Interest rate.
Interest rates is one of them. And then I think it's ICBC, right? I think that was the acronym he has in the book. So that's interest rates, change in sales, business confidence, right? But those things might be given to you in a question like, assume investment shifts up by $50, and then that's sort of in your head, that could be like a reason why in our model, right? But like for now, we just assume it's a constant, right? That doesn't change with disposable income. And the next one is what's G? Government purchases, right? This one, once again, like, I mean, this is more realistic maybe than the investment assumption, but we just assume it's a constant because it's really determined by politicians, right? It's determined by the political cycle. Like, there could be somebody in power for 4 years who wants to spend a lot, and then the next 4 years, somebody who doesn't want to spend a lot, right? Like, it's not really based on national income, it's more based on political objectives that are outside of economics, much of the time. So we're gonna leave it as a constant, sort of just like investment. That's another assumption, right? And then what's the last one? Does anybody know the last one?
Net exports.
Net exports. And this one is kind of a combination of both, right? So it's and then this is exports minus imports, right? And this is kind of like the net exports function is going to be kind of similar to the consumption function. we're going to assume that exports are like government spending and investment, right? We're going to assume that the amount other countries want to buy it from us is like outside of our control, right? That's not too terrible of an assumption. And then this one, we're going to assume is a function of national income. So we're going to assume that we want to import a certain percentage of our national income, or rather we're going to spend a certain percentage of our national income to buy imports. And we're going to denote it by little m. So it's going to be x minus little m times y. Notice it's not yd, we're assuming that it's a portion of national income and not national disposable income, right? Okay. Are there any questions so far? Feel free to just raise your hand at any time through this if something doesn't make sense. So, that's the four components, right? Obviously, I think it was presented to you guys in different models. So like this one, like just C is frugal, and then I think C and I is spendthrift, and then CIG is governed, and then I think all four is opened, right? Really all you need to understand is this full case, because if you understand this, then you understand the other three cases. So let's try and think about how to plot this function. So I'm not gonna give us like numbers or values for these yet, but we're just gonna do it with symbols. Just to sort of show you guys. So basically we can decompose everything into this, right? So I'm just going to apply all of these definitions here and expand everything, right? So we're going to have A plus BYD plus I plus G plus X minus M times Y, right? That's our full sort of expanded thing. And now I'm just going to sort everything into terms that contain Y and terms that don't contain Y, right? Just to get slope and intercept sort of thing, right? So we can just rearrange everything for convenience. A plus I plus B plus X, right? Plus B times YD, but what's YD? Because I'm not looking at the relationship between expenditure and disposable income. I want to look at the relationship between expenditure and actual income.
Y minus income tax?
Yeah, exactly. So I need to do Y minus T here, right? And now I've got Y in there instead of YD, which is good. That's what I want, right? So it's Y minus T minus MY, right? So everybody with me so far? Yep.
Oh, what's a T?
T is the taxes. So the government like raises taxes that are subtracted from disposable income, right? So consumption is a percentage of your income after tax, and then imports, for instance, are just a percentage of income before tax. So I just had to replace YD with Y minus T. Anything else? Good? All right. So I'm still not quite done yet, because now this is gonna, remember that, keep this in your head for later when we talk about the balanced budget multiplier. But we assume in this model that taxes, there's like a net tax rate, right? So the government doesn't just collect a lump sum tax of say like $1 million a year. It collects a certain percentage of national income, right? So we can rewrite capital T here, right, as little t, which is the net tax rate times Y, kind of like we did for imports, right? So now we've got all Y's here, and we're almost there. So we can rearrange everything here. We can simplify to get X. And here I'm just going to factor out Y from these two terms, right? And then, right? And so if we wanted to graph it, this is just a general case, yes?
Sorry, I feel like I'm having a hard time seeing it, it's kind of small.
Oh, my bad, Carol.
Thank you.
No worries. So this is where we end up, right? And then it's easy to see, I mean, it's a little cumbersome, right, because we've got like a bunch of different letters, but this is the intercept, right? And then this right here, multiplying the y is gonna be the slope, right? What do we call the slope of the aggregate expenditure curve in economics? Anybody know? Anybody?
Marginal propensity to spend.
Marginal propensity to spend, I think MP spend maybe. Right? We call it, I think we just call it Z. That's what we're gonna call it for now. So does everybody understand this? It might be beneficial, like write it down and then like convince yourself that this is true, like run through it, because like you're not gonna be asked to actually like manipulate things, but like there's gonna be questions where like if you can understand how we get to the multiplier, you're gonna be able to pretty much answer any curveball questions about it, right? All right. So now I'm gonna give you guys some numerical values and then we're gonna plot it out and then we're gonna sort of answer some practice questions about this stuff. So let's suppose a bunch of things here. So we're gonna first, let's say A equals 100, right? Let's say B is 0.7, I is 200, G50, say exports are 100, and then T is 0.3. So what's this? What do we call this? Because I might not, like, a question might not give it to you just like I have, right? They might say this is autonomous consumption, or, right? So what's this?
Autonomous consumption.
Autonomous consumption, what do we call this? Induced, but B specifically. B times Y is induced consumption, but what is B specifically?
Marginal propensity to consume.
Marginal propensity to consume, investment,
Spending,
government spending,
exports,
exports,
import, marginal propensity to import,
marginal propensity to import. You're kind of seeing a naming pattern here, and then what's this?
tax rate.
The net tax rate specifically, right? The net of any transfers. We assume this is after transfers. So, given this, let's try to plot this curve, right? So, I mean, I've done the math ahead of time because I mean, it's pretty simple, right? So we have AE. AE is going to be equal to 100 plus
According to the body
200
graph.
plus 50 plus 100, right? Plus 0.7 and 1 minus 0.3 times y, right? And this simplifies to 450 plus 0.25y. That's what we call Z, right? And what's that again? Marginal propensity to spend. Spend what?
Disposable income.
No. Income. Right? Because there's no YD there. This is national income before taxes. All right. So this is our aggregate expenditure curve, and hopefully this is a pretty easy line for you guys to plot, right? But I'll do it. The graphs are kind of ugly, so let me know if something's not clear, but Y. And then our line's gonna look something like this, right? It's gonna have kind of a shallow slope. And then this, more on this later, but this is our equilibrium line, right? So every point on this line is a point where AE is equal to Y, right? Based on this, how we've set this graph up, right? So later on, this is gonna help us find our Y equilibrium. But for now, let's label this graph a little bit, right? So what's this number gonna be here?
450.
450. this down there, and what are we gonna call this point here?
Equilibrium.
Yeah, y equilibrium, right? Oh, that's a little wonky. This is YE, right? Now let's try to find what YE is. So, is that what I want to do? So first of all, like, why do we care about YE, right? Like, obviously, this line is telling us all of the sets of aggregate expenditure, right? Like, this is, for each level of income, what is the desired aggregate expenditure? And then this line is telling us what levels of aggregate expenditure are equal to national income, right? So that's why we're looking at the intersection of them here to find our equilibrium. But like in practice, right, AE could be above or below this equilibrium, right? This doesn't just mean like AE is gonna be right here, but this is an equilibrium point, meaning we assume there's like a stabilizing effect that's gonna move the economy towards this, right? So if, let's say, aggregate expenditure, if aggregate expenditure is here, let's say, right? If AE is greater than Y, does anybody know what we assume happens in this model? I think it's called something like the inventory, I should know this, it's the inventory something effect. But it has to do with inventories, it has to do with firm inventories.
Isn't it just when they have more than they anticipated, so?
Well, in this case, it would be more, right? Because expenditure is greater than income. So income here, I'm using all these terms interchangeably, right? But Y is talking about GDP. So like Y is what we produced, and then AE is like what we spent, basically. So in this case, we've spent more than we've made. So what's gonna happen to firm inventories?
It's gonna go down.
They start falling, right? And if you're maybe some of you are taking microeconomics, if you're a profit maximizing firm and you see your inventories are dropping, maybe that's a signal to you that you should increase production, right, and invest more. So that kind of, again, this is a vast oversimplification of what actually happens in real life, right? But we assume that basically firms see their inventories falling in this state, and so they increase production, and then we're gonna come back to equilibrium, right? And then the same thing, if we're below, if aggregate expenditure is below, I should put YE there, right? So if we're below here, and aggregate expenditure is less than income, firms see their inventories accumulating, and then they want to decrease production and bring us back to equilibrium. So that's sort of why we care about Y equilibrium and like what it is, right? Doesn't mean that like our income is always going to be pinpoint this, it just means the economy is kind of going to be pushing things towards that equilibrium point. So let's find it for this thing, right? So all we have to do, right? So Y equilibrium has to satisfy two equations, right? So right? So it has to satisfy. So our point here, we want to find this intersection point, so it's got to satisfy this equation, right? And it's also got to satisfy, right? It's just a system of two equations. Don't worry about this stuff too much, right? But all we have to do, right, is replace AE with YE, because this is an equation we can use, right? So we can just go like this. This all becomes YE equals 450 plus 0.25 YE, right? And then you can just solve for YE. So that gives you I'm not sure if I did yeah, my numerical example is a little different, but whatever that number is, right? Maybe I'll just do it. I just changed the values at the last second because I wanted an easy number to work with, 0.25.
Let's see.
Sorry? Anybody do it? Oh, my bad.
This guy says 375.
It's a guess.
600. It should definitely be
yeah,
bigger because we're dividing by less than one.
Yeah.
Um,
Damn.
Not bad.
Yeah, 600 feet. So that's gonna be what this point is here, right? our example. Are there any questions about that? So all you do is you write out your AE equation and then you change out AE for YE and then you solve for Y, right? Like I just did there. And then that's how you find Y equilibrium. All right, we're almost done. Maybe about 3/4. I just want to talk about the simple multiplier. So I'm gonna show you kind of some math behind it, but you don't need to know this for a midterm. It's gonna sort of maybe help you understand it, but like you're gonna maybe see some scary summation symbols and infinite sums, like don't worry about it. Am I good to erase this? Is everybody, yeah? Okay, so in this case, what is our marginal propensity to spend? We have Z equals 0.25. That means if national income goes up by $1, then aggregate expenditure is going to go up by 25% of it, right? That's what that number means. And so the question is, let's assume that exogenous government spending, right? So G goes up by $100. Now, what will the change in equilibrium income be? So the formula, so what's gonna happen, right? Let's think about this. It's kind of like, it's maybe not the most intuitive thing to understand, but, so the government spends $100, which is gonna do what to national income? What happens when somebody spends $100? It's gonna go up by how much? $100, right? That's what government spending is gonna do, right? Because what have we assumed is that we've assumed demand determines output, right? We aren't allowing prices to vary. This is a very simple economy. We've assumed whatever people desire is what the economy is going to attempt to produce, regardless of conditions, right? So let's say plus 100 government spending is the same, is going to lead to a $100 increase in Y, right? And then what happens when we increase Y, right? What's our marginal propensity to spend? It's 25%, right? So that means that that's going to lead to $25 more of desired aggregate expenditure because government spending led to an income increase, right? Yes.
Can you write bigger?
Sure. So we had and so plus $25 of aggregate expenditure because we've assumed that demand determines output. I think it says that somewhere in the G book. Is going to mean that we're going to have $25 more of national income, which is the same thing as production, right? They're interchangeable terms right now. And then $25 more of income means 25% of that, which I think is like 6.25, right? And then so on, right? This is going to go on to infinity, right? Obviously, in practice, we kind of are just assuming this money's like working its way through the economy, right? But for now, right, this keeps going. I think I actually have the numbers, right? So this is and then 25% of that, right, is going to give us plus $1.5625 of aggregate expenditure. It's going to keep going. It's going to keep getting smaller and smaller. So what's happening here is first, what's happening to national income, right? National income, first, it goes up by the change in aggregate expenditure, right? Which in this case was specifically the example I picked was government spending. But this applies to any of the exogenous components of government spending, right? Anything that will shift the curve. So any of the intercept components, right? And then we had plus 0.25 times the change in AE, right? And then we had plus 0.25 squared times the change in expenditure, and so on, right? this simplifies. So we have, sorry, I should write. This is gonna be the change in, it should all have YE, that's my mistake. Right? This simplifies to delta AE, and I'm just gonna put Z for generality, but remember, like, if that's what we just assumed Z is equal to, right? Times 1 plus, I'll keep 0.25, right? 0.25 plus 0.25 squared plus 0.25 cubed, right? This is gonna go on forever. This is what we call a geometric series, right? And since the value there is less than 1, this, even though it goes to infinity, converges to 1 over 1 minus 0.25, right? Which is the simple multiplier. That's the simple multiplier formula, right? It's 1 over 1 minus MP spend. And that's why it is that way. All you gotta do is remember this though, right? So in this case, what is that? 1.25 is our simple multiplier, right? 4 over 3. No, 1.23. Something like that, right? That's our simple multiplier. Any questions? Again, you're not gonna be asked to prove this. Just know that's, like, I think in the book it just gives you the formula and doesn't say anything. That's why the formula works. So, that being said, if we increase government expenditure by $100, how much is our equilibrium national income going to increase by? Given that our simple multiplier is, so we're looking for, right, we're looking for what is delta YE, which is going to be equal to the change in AE, which is 100, right, times 1.33. So it's going to give us like 133, right? So if we increase government spending by $100, our equilibrium national income will end up increasing by $133, right? That's what we're saying here. So our shift, let's say we shift our curve up by 100, and our equilibrium national income goes from, what was it? It was like 600 to 733. So we change this by 100 and this changes by more than 100. That's kind of the moral of the story, right? Because of this multiplication process. That's why we call it the simple multiplier. Any questions about this? All right. So the only thing, and personally this kind of confuses me a little bit. So I don't know, have any of you heard of, has Dr. Gideon mentioned the balanced budget multiplier at all to you? Okay, so like, it's kind of an assumption, like, it's more something meant to describe a scenario in which the government wants to increase spending and also levy a lump sum tax at the same time to cover that, right? So the reason I find it confusing is because we assume that how taxes work in this model is that it's a percentage of national income, right? It's not just like a fixed amount that the government chooses. So obviously, right, what are the two government's fiscal policy tools in this model, right? What two numbers on this board here can they change?
Taxes and spending.
But specifically which one, right? How taxes, they specifically control taxes via the net tax rate in this model, right? So that, what will happen to the curve, right, is it'll shift, it'll rotate, right? Because we're changing the slope. What the balanced budget multiplier assumes is that, let's say the government decides they want to make a $100 million infrastructure investment, and they're going to finance that with a $100 million lump sum tax, right? So not by increasing the net tax rate, but just saying, this year we're going to collect this much more taxes. What are we doing, right? So what happens to aggregate expenditure, right? So if, let's assume G goes up by $100, but T, we're just going to call it T for now. We're not going to think about it as T, little t times Y, also goes up by 100, right? first of all, this makes aggregate expenditure go up by $100, right? And then that, through the multiplication process, is gonna go through all this and then cause equilibrium income to go up by 133% of that. But when we increase taxes by $100, we're reducing household income, so that's gonna decrease aggregate expenditure. And basically, the moral of the story is that the effect of government spending is like this, and then the effect of taxes is the same thing, except without the first increase, right? So the moral of the story is in this sort of special scenario in which the government says we're gonna increase spending and we're gonna raise a lump sum tax in the same amount, basically this is just gonna change equilibrium GDP by the amount of spending, right? So basically what happens is the government spending multiplies the equilibrium income, but then the tax sort of reduces it. So the overall effect is just to increase it by $100. I think, let me see the book here. But like the key here is to remember that like it requires you to think of taxes in sort of a weird way, right? Like you have to sort of temporarily forget about the percentage tax thing. It only makes sense if it's like an exogenous, like a lump sum tax that will shift the curve. Maybe, yeah, if there's any more questions about that, maybe I can try to come up with a better example, but otherwise that's all I have for today. Yeah.
Could you graph it?
Yeah, sure. So like, I mean, I don't really know if I can graph it, like, because the problem is you have to think about how much it reduces income by, right? So think about sort of like the multiplication process as I wrote it out. So you remember how G, we've seen what happens when we increase G by $100 without doing anything, right? So you've got that. Now what happens when we increase taxes by $100, right? Instead of starting with an increase in aggregate expenditure, right? Because instead of starting with an increase in income, what we're doing is we're starting with a decrease in income, right? And then that's going to go like this, right? So if taxes go up by $100, right? That means is going to decrease by the marginal propensity to consume, right? Right? Because, I think I erased it. Remember, what's consumption? The only thing that taxes affects here, right, the lump sum taxes, is consumption, right? Because consumption is the only thing that depends on disposable income, right? So when the government increases taxes by $100, whoops, that reduces, maybe I should write it like this, right? That reduces disposable income by $100. Does that make sense? Does that make sense to everybody? And then when disposable income reduces by $100, what's gonna happen to consumption? What's the marginal propensity to consume? It's 0.7, right? So this is going to decrease consumption by so that leads to a reduction in $70. Basically, the whole point is that we've right away hit it with a multiplier at the beginning, whereas here, initially, the change in equilibrium income was by the full amount, right? So basically, when we do all the math the same way we did, the only difference is that instead of starting with 1 here, that's gone. We just start immediately with 25% of the original amount, right? So basically, plus 100 in government spending is going to so the multiplier is 1.33, and then the tax multiplier, so the multiplier for decreasing tax is going to be and then so the net effect is just which is 1, right? This though, because of that tax issue, I want to like clear up some things with Dr. Gateman before I say anything more about that, because like I said, you have to assume The textbook says that the only fiscal policy instrument is the net tax rate and not, like, you can't like directly just decide what amount to use, right? You have to take it as a percentage of national income. So yeah, that, I'm probably gonna post an announcement on that later this week because, yeah, I have to ask Dr. Wiggins and things, but that's all I have for now. And if you guys have any more questions, I'm here for another 15 minutes. That's it.